What's up, Mindsetters? We are back. It is term 3. I am Looney, and joining me is Tamlin. Tamlin,
Hi.
how are you doing?
I'm well. How are you?
I'm good, thank you.
Good.
What do we have planned for the Mindsetters?
Well, just to get all the brains going at the beginning of term 3, we've got analytical geometry to get going with today. So many of the grade 10s may very well have started that in class today, and if not, I'm sure it's going to be happening soon. So that's what we're doing.
All right, cool. I'll just send you quickly
Thank
to your board. Guys, we're so excited to be back. It's been a while here, but we're very excited. I hope you guys had a great first day at school. I was reading some of the comments on Facebook. Some of you are a little depressed because you're back in jail and all of that, but some of you are very excited. We're here to help you. Don't forget, we're doing Analytical Geometry I with Tamlin. So I hope you guys are ready. We are on Facebook. Our page is facebook.com/LearnExtra. Our Twitter handle is @LearnExtra. You can download the show notes, the videos, the schedules, and everything you want to know about term 3 on learnextra.co.za/live. It feels so good to be back, and I won't waste any time. Tamlin, I'll send it straight back to you.
Thanks, Looney. Welcome, guys. I hope you're all ready for an exciting lesson of analytical geometry. Just to let you know, this is one of those sections that definitely does follow through in grade 11 and grade 12. So what we're learning today really does form the foundation of those years to come. So it's important that you understand these really basic concepts today. And really, if we understand it, analytical geometry is a really great section. It's a fantastic, fun section to enjoy. Right, so what is it all about? Let's have a look. Analytical geometry. Basically, when we're dealing with analytical geometry, grade 10s, another name we can give it is what we call coordinate geometry, all right? And the reason being is because all of this geometry happens on our Cartesian plane, and it happens where between plotted points on that Cartesian plane. So we do all sorts of different stuff with it. So let's have a look at what we're actually going to be looking at. The first main thing to have a look at with analytical geometry is what we call the distance. Sorry, I've just crossed it out there, the distance formula. There we go. Okay, so the first thing we're going to do today is we're going to do a little bit of investigation just to help you understand where that formula actually comes from, okay? And once we've understood where the formula comes from, we are going to apply it. We're actually going to put it into practice and see how it actually works. The next very important concept with analytical geometry is our midpoint formula. As I'm sure you can guess from the name, what we're doing with that is we're finding the halfway mark between two plotted points on your Cartesian plane. All right? So once again, we're going to do a little investigation just to help you understand where the origins of the formula come from. And then once we've done that, we're going to apply the formula. And then we have a look at the gradients of a line. These are all really crucial concepts with regards to analytical geometry. So the gradient of a line, which you might actually find is actually quite familiar to you from what you've done in grade 8 and 9 with regards to straight line graphs, okay? So some of that stuff might actually ring bells, and you might be quite familiar with some of those concepts. And finally, the key part of all of this is to be able to take all of those different formulas and all of these different concepts and put them together into a mixed example. That's obviously how we have to get used to seeing it, because that's how you're going to see it in your tests and exams. Right, guys, so let's get going and have a look at the key concepts that we are going to deal with in analytical geometry. All right, this distance formula. Analytical geometry is a section that is full of formulas, okay? So you have to learn them, you need to know them, and be very familiar in how to apply them, okay? So the reason why we want to investigate the formula is to help you understand where it comes from so that it's easier to learn the formulas. If you understand why it is what it is, it's easier to remember it, I'm sure you'll agree. So just to give you an introduction to what our distance formula is, this is what it looks like. We've got AB squared, just A and B being the 2 points on the Cartesian plane, and we say AB squared is equal to an x1 minus x2 squared plus y1 minus y2 squared. So if I were to do a very rough sketch just very quickly, if I took, for example, a point A and I took a point B, to calculate the direct distance from point A to point B, that would be then where I would apply that distance formula. Okay. The midpoint formula, this is a nice easy one for us to get easy marks in our tests. It's the halfway mark between 2 points, okay? So again, just to introduce you to the formula, we take XA plus XB divided by 2, that gives you the X coordinate of the midpoint. And YA plus YB divided by 2 gives us the y coordinates of our midpoint. And obviously, this together forms the x and the y coordinate of that midpoint. Okay, right, and then finally, the gradient of a line segment. So as I mentioned earlier, you might find this familiar. You might have actually seen this before, that when I talk about the gradient of a line, I'm talking about the change in y over the change in x. Now, if that's a concept that you've had a problem understanding in the past, I'm going to explain that a little bit more in detail later on. But for now, just remember to put it into mathematical terms. The change in y we refer to as y1 minus y2 over the change in x, which we refer to as x1 minus x2. All right. So that's what we're dealing with today. That's what we're going to be working through. So let's not waste time. Let's get going with our distance formula. Okay. So as I mentioned, we're going to investigate this a little bit. We're going to put it together, and the reason why, guys, is for simply to help you gain a really solid grasp on where that distance formula came from. Okay, so this investigation is going to go like this. We've got a Cartesian plane over here where I've got point A, which is the coordinates of 1 and 3. Point B has the coordinates of 5 and 6. And point C has the coordinates of 5 and 3. Okay, just to bear in mind, you can see that the x coordinates for B and for C are going to be exactly the same. The y coordinates over here and over here are exactly the same. So just showing that we've got a line vertical and a line horizontal. Okay, so obviously creating a 90-degree angle over there. All right. So let's say what we're going to do first of all. Just to clarify, I'm going to refer to this point over here as my xb, and I'm going to refer to that one as my yb. So it's the x and the y coordinates of my b coordinate point. This one over here is my xa and my y, xa and ya. And then let's see over here, this x coordinate was actually the same as the one above it. So let's keep it as xb, and that y coordinate is the one as the same in the horizontal line. So let's refer to that as ya. Okay, so I've just given them names over there just according to where they are on the Cartesian plane. So let's see what we're asking for here. The first part of our investigation is to calculate the value of yb minus yc. Okay, so let's look and see. What is yb? Do you guys agree with me that yb is over there, and that's the value of 6? And yc, which is actually this one over here, it's the same as the same coordinate as ya, is the value of 3. Now, if I subtract them from each other, I'm getting a distance of, or a difference of 3. Okay, all right, so we've got that. Now they've said to us, now what we're going to do is calculate the length of BC. So all I want to know is what is that length over there without actually subtracting coordinate points from each other. So let's literally do jumps. Let's see how many jumps it is to get from there to there. I would have a distance of 1, 2, 3 units. So obviously the distance from B to C is 3 units. Okay? What are we saying there? To help you calculate that vertical distance, we're taking the coordinates, the y coordinate of the top value minus the y coordinate of the bottom, and that gives you the length between the two on your y-axis. Now let's see if we can do it with the x values. So we're going to take xc minus xa. Right, so xc, which is going to be it's going to be 5, minus xa, which is 1. So I've got 5 minus 1, which gives us a distance of 4. Okay, so that was doing it with using coordinates. If I were to do it just by means of jumps, all right, how many jumps do we have? I've got 1, 2, 3, 4. So it's exactly the same length, 4 units. So how do we calculate that vertical length on our axis? We take the y value of your top coordinates minus the y value of the bottom coordinates. How do we work out the x values? x1 minus x2. Okay, so now what we're going to do is they're asking us to calculate the value or the length of AB by using Pythagoras. Okay, so let's see. We've worked out that that length over there was 3 and that length over there was 4. By using Pythagoras to work out my length from A to B, remember your theorem of Pythagoras says AB squared is equal to the length from B to C squared which is 3 squared, plus the length from A to C squared, which in this case was 4 squared. So I've got AB squared, which is equal to a 9 plus a 16, which if we add together gives us 25. And don't forget that you always have to square root it, which is giving you a length of 5. Okay, so are we starting to piece together how we do this? Do you guys agree that your distance formula is actually derived from your theorem of Pythagoras, okay? To work out that direct distance from A to B, what I did is I worked out the distance from B to C and the distance from A to C, and we applied Pythagoras' theorem to it, okay? So let's now take this and actually do it without numbers. Let's work with it in terms of y's, x's and y's and so on, okay? So what I'm going to do is this. We're again going to call this my xb and my yb. That's my xa and ya. This over here, remember, we're going to keep as just xb because it's in line with that coordinate over there. And ya is in line with that coordinate over there, so that's why we're calling it ya. Okay. So the question says write down the length of BC in terms of YB and YA. So your length from B to C can be written as YB minus YA. And the length from A to C can be written as XB minus XA. All right? And ultimately what we're going to then do is write down the length of BC in terms of the x's and the y's. So in other words, I want to know that length over there. So we're going to say my length from A to B squared will be equal to xb minus xa squared, because remember we are applying Pythagoras here, plus yb minus ya squared. And that, you'll recognize from our first screen, was the distance formula. Okay, so the point of that exercise, grade 10s, is to help you to understand that your distance formula is derived from Pythagoras, and what we're doing is calculating essentially the hypotenuse, which is the direct distance from your point A to your point B, by working out the vertical and the horizontal distance between those 2 points. Okay, so that's where it comes from. And I hope that you will remember, so if you have a moment of forgetting your distance formula, you're going to think Pythagoras. Okay. So there it is, guys. I would suggest you write it down, make sure you've got it in front of you, and we're now going to apply the formula. So let's see now if we can actually put this into practice. So this is a question which looks fairly typical, grade 10s. This is the kind of thing you're going to start expecting to see in terms of the questions that you will be asked. Okay. All right, so we have got a diagram below which is showing two triangles. I've got triangle SRP and I've got triangle PRQ. Okay, so we've got those two triangles over there, and we can quite clearly see what each of the coordinate points are. Okay, those are all the points of each of the letters. Right, first question, show the triangle PRS. Triangle PRS, which is this one over here, is an isosceles triangle. Right, what's an isosceles triangle? A triangle with two equal sides. Okay, so two sides equal, the third one not being equal to the other two. So we've got to prove that it's an isosceles triangle. So can you see where the distance formula would come in handy over here? Okay, what we're going to do is use it to prove the length of the side. So let's start. Let's start by working out the length from P to R. So we're going to use our formula and say PR squared is equal to, we're going to take the x coordinate of the one value minus the x coordinate of the other squared plus the y coordinate of the one value minus the y coordinate of the other squared. Okay? So therefore let's call that x1 and y1, x2 and y2. You'll notice that I label my coordinate points all the time. I'm always writing x1, y1, x2, y2. Do that because it actually helps not make any silly mistakes when you're doing these. Okay. All right, so PR squared is equal to x1, which is 2, minus x2. Now please watch out there, that is a negative value. So when you subtract a negative, it becomes positive. And y1, which is 6, minus y2, which is 3, and that again is being squared. All right, so what have we got? PR squared, which is equal to, that's going to be 4 squared, that's going to be 3 squared. And we have got, there's 16, and that is 9. So my distance from P to R squared is 25, but obviously we don't want to know what PR squared is, we want to know what just PR is. So to do that, we take the square root of 25, which is 5 units. Okay, so my distance from there to there is 5 units. All right, so that's fine. Now we want to work out that length over there. Let's see what we've got on that side. So PS. So now we're looking for the distance, I'm going to do it on the side over here, of PS squared, which once again we're going to have the same formula. x1 minus x2 squared plus y1 minus y2 squared. Okay, let's do a quick labeling. This one over here, let's call this x1 and y1, and over here is going to be x2 and y2. All right, so x1 minus y1, x1 minus x2 is going to be 2 minus negative 5. 2 minus negative 5, which again becomes positive, don't forget. And I have got y, which is 6 minus 7. So we've got 6 minus 7, and again that's being squared. So PS squared is equal to, I've got 7 squared, which is going to be 49. And I've got, that's going to be negative 1 squared, which is 1. Okay, so I've got PS squared, which is actually equal to 50. So PS is equal to the root of 50. Okay, so hang on. Right now that's not an isosceles triangle, is it? Because one, the two sides are different in length. But we still have one more side to quickly work out. So let's see over here. The next side we need to determine is this one. So let's work out what the distance from S to R is. And let's see if we have any joy with that. So my distance from S to R squared. Formula, x1 minus x2 squared, y1 minus y2 squared. Let's quickly label. I'm going to call this, let's call this x1 and y1, and then we can call that x2 and y2. It doesn't really matter which one you call which. As long as you keep the x1 and the y1 together in one coordinate pair, that's fine. Okay? So 5 minus negative 2. 5 minus negative 2, which is going to be 5 plus 2. And I have got 0 minus 3. 0 minus 3. Okay, this is looking promising. I've got a 5 plus 2, which is 7. Okay, that's going to be, am I right? 5. 49, and I've got a 9. No, I think I've made a mistake somewhere in my working out over here. Grade 10s, I'll tell you what, you guys can check me, and I think we're time for a short break. But what I want you to check, please, is one, we're going to come back and check it. They should be the same, but we'll check that when we come back, okay?
Okay, cool. Guys, we are going to take a very short break. Before we do, I'd just like to send a shout out to Apiwe Gift, Kamva, Spesihle Phakade, Julian Bongingosi. Thank you so much, guys, for tuning in. There are a lot of you. I'll mention more of you after the break, but we're all going to take a very short break, so do stay tuned. Welcome back, Mindsetters. I hope you guys are refreshed. You're ready to go again. Just before we go, I'd just like to send a special shout out to Nzovo Makamu Kamza. He's actually in grade 12, and he says he's on the page just to help the grade 10s so that they can get full marks. So nice one to you. So what he's asking, Tamlin, is that ask our teacher if it's necessary to write down the units for distance, for example, 4 units, because as a grade 12, you get penalized for that.
Okay, absolutely. What you want to do is at the end of the question, once you've actually sort of answered the final question, yes, please write units there, because that is what you're working out. You're working out a distance, and a distance is in units, whatever those units may be. Okay, so let me show you over here. All right, sorry, the silly mistake that was being made is I was using that coordinate over there, which has got nothing to do with triangle SRP, so that was my silly error. But having done the calculations, what we can see in blue here is that the length from S to R, which I hope you guys worked out as well, is also the distance of 5. Okay, so this is what we should write. So making sure you answer the question we write there. Therefore, triangle SRP is isosceles. And the reason being because your distance from S to R is equal to your distance from P to R, which are both equal to 5 units. And as a result, yes, it's an isosceles triangle. Okay, all right, so yeah, absolutely, the question answered. Do write units there, please. It is part of the answer. All right. Okay, next question. No, we're jumping backwards here. All right, next question with regards to the same diagram. Now what they're wanting us to do, so let's just fill in quickly what we know here. We knew that that distance was 5, and we know that that's 5. And we've actually worked out that that's a root 50 over there, which we're going to leave like that for now. Okay, so show the triangle PRS is right angled. Okay, so now we're still looking at this triangle over here, and they're wanting us to prove that it's a right angled triangle. Okay, how would I do that? Bearing in mind that the distance formula is really the only tool that we've actually been taught at this point. I hope that what's coming into your mind is Pythagoras, okay? Bearing in mind that I've now found the length of the 3 sides of the triangle, if I can prove Pythagoras, or if I can prove that Pythagoras works, it would make it a 90-degree triangle. So this is what I mean. Let's take that angle over there. Let's assume that's the 90-degree angle, or would it be? From S to R. No, hang on, sorry, I'm filling in my sides. Let's just take that away. This one over here, SR was 5. And RP. So let's just get our sides correct so we don't make any silly mistakes. RP and SR were the two that's the same. Right, so SR and RP. So that one over there was 5. This one over here was the root of 50. Okay, so it looks to me like that's going to be the 90-degree angle over there. And okay, so working with it as that, let's see if we can prove Pythagoras. If this is a right-angled triangle, do you guys agree that we would be able to prove this? My length from S to P squared would have to be equal to my length of SR squared plus my length of RP squared. Okay, that would be the theorem of Pythagoras. So as I've said, if I can get a left-hand side to equal a right-hand side here, it proves it's a 90-degree triangle. So SP is the root of 50, but bear in mind that that is being squared. My length from S to R is 5, and again it's being squared. My length from R to B is 5, and it's being squared. So the square root of 50 squared, please remember that a square root and a squared cancel each other out. We're left with just 50, which is equal to 5 squared is 25, and 5 squared is 25. So we have got a left-hand side which equals a right-hand side here, which means that your theorem of Pythagoras is true, which therefore means that triangle PRPS is a right-angled triangle. Okay, all right, and we did that just by using our distance, knowing our distances. Okay, right, let's see what else we can do with this triangle knowing distance formulas. The next thing they're asking for is to prove that PRQ is a scalene triangle. So PRQ being the bottom triangle. Okay. So the idea here, guys, is again, we're wanting to prove it's a scalene triangle. So we're wanting to prove that we've got a triangle with 3 different sides. Okay. So let's quickly put our formula to practice again, and let's actually work out the 3 different lengths over there. So let's start with my length from, let's make it the color pink, and we're going to start from P to R. So let's call this x1 and y1. Let's call that x2 and y2. So PR. So my distance from P to R squared is equal to my x1 minus my x2 squared plus y1 minus y2 squared. It's always a good idea, grade 10s, to write the formula down first. It just sets you up so you know what needs to be where, and you have it clear in front of you. So I would really say write the formula in its standard form down first as a starting point. Okay, so PR squared. From x1, I've got a 2 minus x2. Okay, here again, you've got a negative, so please watch out. 2 negatives give you positive. And I've got y1, which was, in fact, we already know this length, minus 3. And in fact, we already worked out earlier that this distance from P to R was 5. So let's not waste any time there. We know that that's 5. Okay. Let's make this one blue. I'm going to work out the length from here, from P to Q. All right, so in blue, I'm calling that x1 and y1, and that's going to be my x2 and y2. Okay, so my distance from P to Q. PQ squared, x1 minus x2 squared, plus y1 minus y2 squared. Okay. PQ squared is equal to x1, which is 2, minus x2, which is 5. 2 minus 5 is negative 3, so let's just save ourselves a little bit of time there. That's negative 3. And y1 minus y2, y1, which is 6, minus y2, which is 0, so that's going to stay just 6, and that is squared. So what have we got here for PQ squared? I've got a 3 squared, which is 9, and I've got a 36. 9 plus 36 is going to give us 45. And the square root, don't forget to square root at the end, guys. Remember, it's the square root, which is giving us the distance of PQ, which is root 45. Okay, so PR right now we know is 5. PQ is root 45. I think we're on our way to proving it's a scalene triangle. The 3 lengths are not the same. All right, last one quickly. We've got this length over here. Okay, so let's erase. Let's get rid of that so we don't have any confusion. And let's make it in green just so we know what belongs to what. That's x1 and y1, and that's x2 and y2. Okay, let's see if we can fit it on the side here. So we're looking for RQ squared. All right, I'm going to save a little bit of time here and not write the formula simply because we're just wanting to get through it. Okay, so negative 2 minus 5, that's going to give us a negative 7, and that is being squared. I've got a 3 minus 0, which is going to stay 3, and that's being squared. So my RQ, I've got a 49 plus 9, and 49 plus 9 is giving us RQ squared, which is 49, 59, 58. And the square root of that I'm going to leave in surd form. We'll remember the word surd form. You leave it in its square root form, is root 58. Okay, so what have we done? We have proven that all 3 sides are different in length, so therefore triangle RQ, what was it, P, is a scalene triangle. Okay, all right, and just make that statement at the end so that you have actually answered the question that was being asked of you. Okay. All right, I hope we're getting the idea. Let's quickly have a look at one more distance example, and then we're going to look at some midpoint formula. Okay, this is a slightly different twist on just the way that they could ask us. And what they've said over here is, if the length of the line segment joining the points A, which is the coordinate point 1 and 2, and B, which is the coordinate point x and 6, it's equal to 5 units. Determine the 2 possible values of x. Okay, so what I'm going to do quickly is let's put this into picture form and actually plot it. Okay, so we've got point A, which I said was 1 and 2. So there's 1, there's 2. Let's call this over here point A. And I've got point B. Now this is slightly tricky because I don't know what the x coordinate is. I know what the y coordinate is, but we don't actually know. So we're going to have to estimate, okay? So I've got an x value, which I don't know, but I've got a y value, which is 6. So let's put it a little bit higher over there. So what we basically know is that whatever point B is, it's somewhere along that line over there. I'm going to move it up a little bit. There we go. That's where it's supposed to be. Okay. And we know that the distance from A to this line over here is 5 units. So do you guys agree it could be anything in that direction, or it could be anything in that direction? Either of those could give us a distance of 5 units. Okay? So does that diagram then make a little bit of sense in the fact that you wouldn't only get one answer for x here, you're going to get 2. Okay? So how do we actually put this into practice? So we're going to start with our distance formula, and we're going to say the distance from A to C, no, A to B, the distance from A to B squared is equal to the formula of x1 minus x2 squared plus y1 minus y2 squared. Okay, what do we know about the distance from A to B? All right, if we look at it carefully, they've already told me that the distance is 5, okay? But here's where you've got to be careful. It's not just AB in your formula, it's AB squared. So when you fill it into your equation, watch out over there, we need to write that in as 25. Okay, so guys, watch out for that, which is equal to this over here. Let's call that my x1 and my y1 coordinate. This over here is going to be the x2 and the y2 coordinate. So x1, which is 1, minus x2, which is just an x, we don't know what that is, plus y1, which is 2, minus y2, which is 6. Okay. So what does that give us? I've got 25, which is equal to, do you guys agree with me over here? We have got a FOIL sum. We need to FOIL that out, okay? So foiling that out, we're going to get a 1 minus 2x plus x squared. I hope after your long holiday you remember how that all works. And I've got 2 minus 6, which is 4, and that's going to be squared, so we've got 16. Okay. Right, what type of equation do we have here, grade 10s? We're solving an equation with an x squared in it. So do you remember we're solving a quadratic equation, okay? So we're throwing in a little bit of equation theory here. Remember, quadratic equations, all the terms need to move to the left-hand side. You want your right-hand side to be equal to 0. So therefore, this is what we're going to have, 25. Let's move everything over, and then I'll tidy up after that. So everything's coming over. All my signs are changing. And I've got equals to 0. And then let's tidy that up. So what have we got here? Okay, so we have got negative x squared. Okay, so that's gone. I have got a 2x, a plus 2x. So that's gone. 25 minus 1, which is 24. And 24 minus 16. I just don't want to make any silly mistakes, so let's make sure. 24 minus 16. Okay, we got 8. All right, and it's 8. Equals 0. Okay, just remember with quadratic equations, we're not crazy about that minus as the first term over there. So what I'm going to do is essentially divide everything through by a negative, and then we get rid of that. So all the signs have changed. Right, how do we solve this? We have to factorize. We factorize our trinomial. Factors of 8 is 4 and 2. That's going to be minus, and that's going to be plus. Giving me two answers for x. I've got x is equal to 4, or I've got x is equal to negative 2. All right, so let's see if that makes sense in our diagram. X was equal to 4, or x was equal to negative 2. I think that that works. That looks right. So that's how we would go about doing that. Okay, grade 10s. So that's the distance formula. I hope you guys have got a good grasp on that. It's not a difficult one to use. Label your points. One of the biggest mistakes that gets made with analytical is silly mistakes. Okay, so watch out that you are substituting the right points in the right place. Okay, so take caution with that. Okay, Looney, do we have time for a short break before we move on to midpoint formulas?
Yes, we can take a short break.
Okay,
Cool. Guys, we are going to take a very short break. I see on our Facebook page a little birdie has posted a birthday message for me and my picture. So thank you so much to the guys who commented and wished me a happy belated birthday. I did turn 21 on Friday. I didn't want to mention my age, but yeah, I turned 21. So thank you guys for sending me all that love and all those birthday wishes. We are going to take a very short break, so we'll see you straight after this. Welcome back, Mindsetters. I'd just like to send a shout out to all the grade 12s who are on the page who are so mesmerized by this lesson. You guys, I can see you guys want to go back to grade 10. You're enjoying the show and you're having fun. Shout out to Tabang Molele, who's like, this show is unbelievable. So shout out to you. Thank you for watching and thank you for helping the grade 10s on the page, guys. You guys are awesome. I know the grade 10s are going to pass just because of the grade 12s are helping them on the page. So we'll take it straight back to Tammy.
Thank you. Right, let's not waste any time. We've got the midpoint now to have a look at, so let's get going with that. Guys, this one over here, I'm sure you can see is not a very difficult one to work out, so enjoy them when you get them in your test, okay? We've got point A and point B, and basically what they've asked us to do here is to calculate M, which in this case they've told us is the midpoint. It's the halfway mark between point A and point B. Okay. The formula, without wasting any time, is as follows. To work out your point M, we are simply doing this. We're going to take the two x coordinates. So I've got an x1 plus x2. And I halve them. I divide them by 2. All right? And that gives you the x coordinate of your midpoint. Okay, I've got my semicolon because remember, we're working out a coordinate point here. And then we follow it with a y1 plus y2 divided by 2, and that will give you the y coordinate of your midpoint. So if I were to actually work it out over here, let's see what we've got. To work it out, I'm going to say my midpoint is equal to x1, which is 2, plus x2, which is 8, divided by 2, and y1, which in this case is 1, plus y2, which is 3, divided by 2. Okay, and that's your midpoint coordinates. So what does M then give us? That's 8 plus 2, which is 10, and 10 divided by 2 is 5. And 1 plus 3 is 4, and divided by 2 is 2. So does that work for us? I've got 1, 2, 3, 4, 5. That x coordinate over there is 5, and the y coordinate over there is 2. So do you guys agree with me? We've got our midpoint. Okay. All right, so not a difficult one to apply, and as I say, enjoy them when you get them in your test. They're quite fun to actually do. This one I like because it's a slightly different twist on it, so I do just want to show you just so that you are familiar with it. And even those grade 12s who are watching, guys, you know that these questions come up, even in that grade 12 paper, okay? So, determine the value of x and y if M is the midpoint. Okay, now watch the wording over here. They're telling me that this is actually the midpoint of the line segment joining A, where I've got the coordinates of x and 1, and B, where I've got the coordinates of 8 and y. Okay, so let's just consider this over here. The formula says that the midpoint is equal to x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So what we're going to have to do is this, guys. We're going to separate it into two different sums. We're going to work the x coordinate first and then the y coordinate second. So let's see. Do you guys agree that the x coordinate of your midpoint is actually that 5 over there? All right. So therefore, the x midpoint, that point over there, is actually equal to 5. All right. So this is my first sum. We're going to say that 5 is actually equal to x1, which in this case is just x, plus x2, which is 8, divided by 2. Now instead of dividing on that side, the opposite of divide is to times. So I'm going to multiply 2 up on the other side. And we are going to have a 10. And if I bring 8 over, I'm going to subtract it to give me 2 as my x value. All right? The y coordinate of the midpoint, they told me, was 2. So the y coordinate is equal to that 2 over there. So now similar story. We're going to say the y coordinate, which is 2, is equal to y1 plus y2 over 2. All right? Which would mean that I've got 2 times 2, which is going to give me 4, equals 1 plus y. And when we bring 1 over, we'll subtract it. So therefore, 3 is equal to the value of the y. Okay, so that's a nice question, guys. I think that's a good grade 10 midpoint type question. They actually give you the midpoint, and you've got to work backwards to find the missing coordinate. So watch out for that type of question. That's a very, very possible one. All right. Okay, now let's quickly have a look at gradients. When we consider gradient, the first thing which I'm sure you would recognize is that gradient has got to do with the slope of a line, okay? So a slope being either the inclination or how it's going up or down in terms of its steepness, all right? So what I'm going to say is that let's consider climbing a set of stairs. I think that's a good analogy in terms of working out gradients, all right? We said earlier that gradient was the change in y over the change in x, all right? So I want you to imagine standing at the base of a flight of stairs, okay? In order to climb up that flight of stairs, do you guys agree you would have to start by taking one step up, all right, which if we're thinking in terms of coordinate geometry would be a y change, and we would take one step across, which would be an x change, okay? And as we go up the stairs, so as we go up, I take one step up and one step across. So change in y over change in x, and change in y over change in x. And as you do that change in y over change in x, what you're doing is you're climbing up that flight of stairs, okay? So the gradient is being created, the slope of that staircase is being created by the change in the step up over the change in the step across, okay? What about if I had a flatter, less steep looking staircase, okay? In this case, what I would do is I'd take a shorter step up and I would have a longer step across, all right? However, it would be followed by the same thing, a shorter step up and a longer step across, and so on, all right? And that type of inclination would give us a different type of gradient. It would give us one that's less steep. However, both of these two gradients, do you guys agree, is climbing up the staircase, okay? So that's our positive gradients, all right? So going from left to right, it's heading up. If I had a staircase, in this case, what we're doing is we're actually standing at the top of the stairs and we're going to come down the staircase. And in that case, to get down the stairs, we're going to follow the similar thing. We're certainly not going to take a step out first because we're going to land up falling. We're going to do a step down first and a step across. So by taking a step down and a step across, we take our first step down. And so we go. And that will then get us down the staircase safely, all right? And that gave us a negative gradient, all right? So that's where the concept of the change in y over the change in x gives you the gradient of a line, okay? So putting it into a formula, when we talk about the change in y over the change in x, remember we're talking about coordinate points here. So we have x's and y's. So the way we do it is we say the change in y, which is y1 minus y2, over the change in x, which is x1 minus x2. Guys, a critical thing to remember is that it's not x over y, it is y over x. And if you forget that, think about standing at the bottom of the stairs and ask yourself, what do you do first? Do you take a step up first or across first? And I think you agree, if we're standing at the bottom and took a step across, we'd trip and fall. So you take a step up and across. So it's y over x. Okay. Let's do a quick example of this just so we've got this over here. We're looking for the gradient of line AB. Okay, that's our notation. So we're going to say y1 minus y2 over x1 minus x2. For anybody who may have learned it at school as y2 minus y1 over x2 minus x1, guys, that really doesn't matter, okay? The important thing is this. If you have y1 minus y2, it must then be followed underneath by x1 minus x2, or vice versa. So as long as you just keep that order correct, then you have no problem, okay? All right, so let's quickly label. I've got an x1 and I've got a y1, x2 and y2. Okay, so the gradient from A to B is going to be equal to y1, which is 3, minus y2, watch out, there's your double negative, it's going to become positive, over x1 minus x2. All right, so in this case, I've got a 3 plus 7 over 1 plus 5. That's giving me 10 over 6, which if I were to simplify it, what will give us 5 over 3. Okay, so This over here, if we were to take a staircase, it would be quite a steep step up and a short step across. And it would be a steep step up and a short step across, hey? Because your y is a bigger change. And we're climbing up the stairs, it's a positive gradient. Okay, right, I hope that that helps you. Quickly before we go, guys, just a few important things regarding gradients and coordinate geometry. All right, first things first. If we've got two lines that are on a Cartesian plane and they are parallel to each other, all right? Consider the lines that are parallel. They would run equidistant from each other on your Cartesian plane. They're never going to get further apart and they're never going to get closer together. What could we say about their gradient? What would be clear about the two gradients if they were parallel? Having a look at it, that line and that line are parallel, which means they are going to have the same gradient. And that's really important because when we do more sort of mixed examples, that comes up all the time. So parallel lines have got the same gradient, okay? And what would happen if I have lines like that? I've got one line heading in one direction, and I've got another one heading in absolute opposite direction, and they hit each other at a 90-degree angle over there. So in other words, they are perpendicular, all right? What is it about the gradients that is special with perpendicular lines? Well, let's look at it like this. The first thing, this line over here, do we all agree, is in a positive direction. That's climbing up the stairs. This one is in a negative direction, and in order for them to be perpendicular, that's always got to happen. One's got to be positive and one's got to be negative, okay? So first things first, our two gradients will have opposite signs, all right? The other thing is then going to be this. If this gradient over here was 3, let's just say that that's the gradient, okay? What we do with a perpendicular gradient is we have to invert the gradient, which means we have to flip it over, all right? And it would always then have the opposite sign. So if this gradient over here was a 3, this one over here would be negative a third, all right? So the perpendicular gradients are the inverse of each other with the opposite signs, okay? So how do I put that into a mathematical formula? We say that the gradient of the one line multiplied by the gradient of the other line have to give you an answer of negative 1. All right. That's what you're going to put together if we ever talk about perpendicular lines. So just as an example, if I had a gradient of 2/3, the perpendicular gradient to 2/3 would be negative 3/2. And if I were to cross-cancel, the 3's cancels and the 2 cancels, and I'm left with negative 1. Okay, so that's what you've got to remember. Parallel lines, same gradient. Perpendicular lines, we flip the fraction over and we change the sign. That's how we work out how we get the perpendicular gradient. The formula to remember, the gradient of the one times by the gradient of the other equals negative 1. All right. Do I have an example to quickly practice on? All right, let's do this one over here before we run out of time. Okay. My line from A to C, we're wanting the gradient from A to C. So I'm going to say y1 minus y2, which is a negative, so it'll end up being positive, over x1, which is a 1.5, minus x2, because again it's a negative, it becomes positive. So that's going to be 9 over, I've got 1.5, which is 3/2. 3/2 plus 3. When you work it out, it's going to give you an answer of 2 as a gradient over there. Okay. All right, guys. So basically what we've done today is just introduced you to the basic concepts of distance formula, of midpoint formula, and of gradients of a line. Okay. So what you now need to do is listen carefully. You guys are going to go on to Curio this week, and we are going to start posting some questions which involve a little bit of application of these concepts, okay? And we would really like you guys to go and try them, okay? Go and put this theory into practice and see how much of it you are understanding, all right? The code of the Curio, if you want to write this down, is M10, all right? And the directions or instructions on how to actually go into the Curio is all on the website. So I'm sure it's easy enough to get in there. Go and practice them, guys, because this is a section we really want you to do well in. Okay, so that's your homework for this week. What I'm going to do next week is then take those questions and explain them and elaborate a little bit more on them and actually give you the full picture in terms of what you need to know for analytical geometry. That's all from me for today, so thank you so much.
Thank you so much, Mindsetters, for joining us. Like Tamlin said, you have homework, so remember next week when she's here, she will help you guys, so you must watch, okay? Remember to tune into Connections at 7:15 tonight. They're talking self-starters, but from us, it's a goodbye, guys.